Okay, so just two things in today's lesson. You have two kinds of problems, that's it. This whole unit was about applying lines and exponentials and just learning them a little bit better, right? But mainly applying them. We learned how to use them for scatter plots. We learned how to build basic models with them. So we're going to do another couple little things with just lines here at the end, which is you should be able to find a line between 2 points. This is an essential skill. Almost every year, my students walk into Algebra 2, except for the last 2 years. And students I get from other schools and stuff never know how to do this. And it's a super essential skill. So if you can't, you're going to have trouble. So it's very important, okay? But it's not that hard. So can you guys remind me, what's the equation of a line? We know what one is. There's a few different ones, but you just really need to know one. Y equals what? Yes, nice. Love it. It's called the slope-intercept, right? Because it's got a slope and it's got an intercept. So students I get from other schools always do strange things, like try to graph these points, which isn't a bad thing. I mean, you can plot the points and try to draw the line through there and then try to guess the line. That's really inefficient and not the good way to do things. You don't need to graph these at all to figure out their slope and their intercept and put the equation together. So I don't want to see anybody graphing points here, okay? All we need is the M and the B, and then we'll graph our line from the form, okay? That's the point here. This whole little unit we've been doing is about developing the equation for things, whether it's a line or whether it's an exponential curve. So let's figure out the slope first. So M, what is slope? I think you guys are doing a pretty good job in the last unit of telling me what slope was. Slope was like something over something, right? It's the same thing you use for average rate of change, right? What goes on top? Rise. Or like the vertical parts, because sometimes it falls instead of rises, right, if it's negative. And then on the bottom is the run. Very nice. Okay, so you can write this all kinds of different ways. Like there's formulas, there's all kinds of things. I'm going to write it a few different ways. You don't have to write it all those ways. Find one you like, okay? So on top we really just have the y's, and on the bottom we really just have the x's. If you've got that in your head, that's really enough, as long as you don't flip-flop it. If you flip-flop it, bad things start to happen, so don't do that. All right, so y's. What are my y coordinates for these two lines? Because I'm going to make a line that goes through these 2 points, not just any 2 points. -3 and 1. Should we do it the same way that we did it with average rate of change, though? Because that's what we're doing here, really. Usually, it doesn't matter. This would work. But usually, didn't we pick the second one? Just to be consistent, so we're not feeling like it's new. Let's just pick the second one first, okay? It doesn't really matter. Like I said, it didn't matter in average rate of change either. What's got to go in the middle, though? Minus. Minus for change, because the slope is all about like that slope triangle, and that slope triangle is about the distance between 2 points. The rise is the vertical distance between. Distance in math is minus. You put your x's on the bottom in the same order. Whatever order you picked up here, stay consistent. So what should go below 1? 4. What should go below -3? 2. And the distance, we're going to put a minus. If there's another minus there, so what? Like there is on this one, right? Coincidence. It's got to go there too. But this minus comes from the distance between them. Okay. All right, so let me just simplify. Minus minus is plus. 4 minus 2 is 2, right? So that's 4 over 2. All right. That one worked out to have a nice, simple slope. So, think of this as cooking. You're finding ingredients. This is your product that you want to achieve. You've got the first ingredient, you need the second ingredient. So let's write it down. 2x plus b. I just need b. Just one thing left to find. And I want the line, remember, to go through these 2 points. If it goes through those 2 points, then both of those points have to satisfy the equation. So you can pick whichever one you want and stick it in and make sure it's satisfying it. So which one do you guys want to pick? Doesn't matter. 4-1. 4-1's nice and positive, right? That's pretty easy. So xy, right? So what goes in for the y? 1. What goes in for the x?
4.
4. Write the rest of the stuff down. That's all for b. So simplify. That's 1 equals 8, right? How do you get b by itself? That 8 is in my way. I need to chuck it over to the other side.
You gotta subtract.
I need to subtract it. Nice. So 1 minus 8, what's that?
So negative 8 equals 8.
No, 1 minus 8 is not negative 8.
7.
Negative 7. Yeah. Okay, so circle that, circle that. You've got your 2 ingredients. Don't forget to like put them in the oven. So this is going to be 2x minus 7. That's the line. If you needed to graph it, we know how to graph lines like that. So I know that the problems in the book don't say graph the line. I want you to graph it anyway. Okay? So let's graph this. Just a little sketch. You don't have to make it elaborate. Remind me, where do we start? Do we start with this or do we start with the slope? We start with the intercept. Negative 7 is the y-intercept. 1, 2, 3, 4, 5, 6, 7. There's the first point. Slope is what again?
Rise over 1.
Up 2 over 1. Line. Done. Okay? Let's do it one more time. So you guys tell me. First step, find the...
First step, find rise.
Find the rise over run,
Or
yes.
the y's,
Right, so we're going to do the y's. 10 and negative 2. Minus in between. 3 and 1 with a minus in between. So that's going to be 10 plus 2 over 2, which is 12 over 2, which is 6. That's m. Right? Then I stick it into my equation. My equation is, of course, mx plus b is y. So I'm going to stick that in as m. So that I have y equals 6x plus b. Then I'm going to stick in, look over in your notes or whatever if you need to. One of the x values and one of the y values. So which one do you like better?
3 and 10.
These are smaller, those are positive. You like positive
Positive.
better. Yeah, okay, all right, we'll go with this one. So we're going to say what goes here then?
10.
10 is the y. 6
Times
times 3 is the x.
Plus b.
3 plus b.
So we've got 18 is 10 plus b. We just need to get b by itself, so we've got our second ingredient. So
Minus 18 on both sides. Negative 8.
put them together and you're done. So what's the line? Just again, I'm just going right back up here and sticking them in.
Y equals 6x plus negative.
Plus negative 8. Now, you don't have to say plus negative, because plus negative is negative, right? So you want to go like that. And then if we graph it, man, this line's going to be steep or flat?
Steeper.
Crazy steep. Very steep. 6 steep, in fact. So we got to start from negative 8. Go up 6 over 1. There's our line. All right. Let's look at one more kind of problem. So, one more thing. It doesn't require much extra of than what we just did. In fact, I think this is easier. The key is that you understand what it's asking you. So, this says find a line, and then it's got a crazy symbol. What's that symbol mean? Any ideas? Got like 2 little lines right next to each other.
Parallel?
Yes.
Oh, yeah, boy.
That's a symbol for parallel. There's another symbol out there. I'm just going to introduce it today, even though we're not going to do this until another time. This is the symbol for, any ideas?
Horizontal.
Perpendicular.
Perpendicular, right? Nice. You can do parallel and perpendicular problems like this just to make it simpler. We don't need to know everything right away. I'm just going to do parallel with you today. Okay, perpendicular is just about as easy. Unless you guys want to be ambitious, we can do those too. Let's do this one first though. Okay, so the key here is that you realize you're creating a new line and there's already an old line that exists. So to make that extra clear, let's graph the old line first. All right, so the old line's 3x plus 8. Help me. Start up 8. And from there I rise 3 and run 1, because there's a 1 under there.
Oh, yeah.
1, 2, 3. Still kind of steep. So I guess not a big variety of lines today. All of them have got a nice steep positive slope. So there's the old line. I want a new line. And I want a new line that goes through that. I'm not going to do this graphically again. I'm only putting that on there. The only reason I graph that at all is for practice for you guys, and so you could understand that there's already an old line that exists, and we want a new one. And we want to make it parallel.
So that means it has to be the same thing, it's just going a little bit over.
Yeah, exactly. But we're not going to use our graph to do that. We're just going to use the algebra we just did.
Yeah,
So-
8 equals 3.
Yeah, great. I love it. You're already on it, man. Nice. 10 equals...
3 times 4 plus 8. Oh, B, sorry.
No, that's great.
No, well,
He had a great idea. He's using the point that we just had. He's putting it in the right spots for mx plus b, right? The key is that that's the old line. You could even subscript it with like an O for old. And that now we've got a new line. You can subscript that with N for new if it made it real clear that there's two different lines. And then you're going to be plugging in the info you know into the new line, which is what Hunter was already doing. He said the new Y we want to go through is 10. The new X we want to go through is 4. Why does this stay 3? Because that's what parallel means. Parallel means what about the slope?
Stays the same.
Slope stays the same. Because exactly like Kleina was saying a second ago, if we're going to make this parallel, we're going to have to do something like this, right? It's going to have to be either like that way, or like it can be up this way, depending on what point we want it to go through. So either way, my arm is not changing. The slope or the average rate of change is still staying fixed at 3. So that's why this 3 stays the same. Now is the intercept going to change? Look at my line.
No?
If it goes here, the intercept was there, now it's way different, lower. If I go up here, the intercept's going to be way different and higher. So this is going to change. I don't know what it is yet. It's negative
Now
2.
now I get it. That's what
Yes, ma'am, it is. So the new line we want still has 3x, except its new intercept is negative 2. Let's graph that and just see if this looks like it's right, like ballpark. Okay? So like negative 2 is down here, up 3 over 1. If I drew that right, then it should be nice and parallel. Do you guys think that that might go through 410? Let's see. Let's see, 1, 2, 3, 4. I don't know. My line is this is a pretty bad sketch, but yeah, a point on here is supposed to be 410. I don't think I did a very good drawing, but you guys get the point, right? That's why students who try to do this kind of math by just drawing, they always mess up because they're never that good at drawing. Even if you use graph paper and a straight edge, you're still probably going to mess up. It's so easy to do this too, if you just go through the process. It's a little easy process. You picked it up before I even said what it was, pretty much, right? So, that's it. I'll see you next time.